Okay, on this next one, they already gave it to us in terms of fourths. That's nice because you're going to see here in just a second why. But so we start with the same setup where we're going to bump the 13 fourths over, and then we're going to take half and square it, and that gives us 9 fourths. So I'm adding 9 fourths and subtracting 4 fourths. So adding 9 fourths is going to give me the x plus 3 halves. And then 13 fourths minus 4 fourths is 9 fourths. Does that all make sense to you so far? And then what this really means is 1.5. And then do 9 divided by 4. Let's get that decimal. How'd you do? Did you get 2.25? So my vertex is at 1.5, 2.25. Let's go graph that. Now, what if we made every line on our scaling a quarter or 0.25, 0.5, 0.75, 1, 2, 3. And then going out, what if we went by halves? Okay, well, that means I'd be going to put a dot at negative 1.5 up 2.25. And then from there, I'm just counting parrot stretch. So it's going to be out 1, up 1. But be careful of your scaling. So do you want to scale by quarters so that you can make it land on corners? Or would you rather just make it work, in between lines the way we normally do? So your line of symmetry is going to go through negative 1.5. Anyways, just an alternative way of graphing. If you graphed it by ones, you're totally fine. All right, next one is a 1/2 in front. When there's a coefficient in front, we need to divide that out. So here we have how many halves are in a negative 1. Half divided out of 1. How many halves in negative 1 is negative 2. I don't know if that makes sense for you guys. Keep, change, flip might make more sense. And then we're bumping the 5 over for now. Then we're going to do the B work on the negative 2 divided by 2, or negative 1 squared. 1 times 1 is just 1. So I add 1 half times and I minus 1 half times because of that coefficient. So I'm going to get 1/2 x minus 1 squared, and then 5 minus a half is 4.5. 5 minus a half is 4.5. All right, so my vertex is at 1, 4.5. And we go right 1, up 1, 2, 3, 4.5. And then I'm counting stretch of a half. So out 1, up a half on either side. Out 2 would normally be 1, 2, 3, 4. We're going to go half of 4 or only up 2. You're going to get a nice wider shaped graph based on the stretch of a half. Line of symmetry is through x equals 1. Okay. One of the parabolas in problems 9 and 10 should look wider than the others. Identify that parabola. Why should this one look different? So number 10 is wider because the stretch is 1/2. This means the graph is growing half as fast as parent. Okay. The next section is on completing the square, where you do B work when the middle term is not ideal. So -11 divided by 2 squared is going to be 121/4, where it's top times top. 11 times 11 is 121. And then bottom times bottom is 4. 7/2 squared, 49/4. 15/2 squared, 225/4. Leave the number that completes a square as an improper fraction, then write the trinomial in factored form. So it wants you to give the other form of all these, the x minus 11/2 factors, the x plus 7/2 factors, the x plus 15/2 factors. All right, this one gives us a 2/3 divided by 2, or 2/3 keep, change, flip, where we get 1/3. So taking something and dividing it in half is going to yield what's half of 2/3. Doesn't that make sense? 1/3. And then we square it, so it gives us 1/9. Over here, same thing, where we're going to multiply it by half. So that's going to give us 1/10. Square it. And then finally, 3/4. We want half, so that's 3/8. And then we're going to square it. And that gives us 9/64. Here comes the factored form of this. It's the x plus 1/3 squared factors. It's the x plus 1/10 squared factors, and the x plus 3/8 squared factors.